Hi guys, Steve Woods here from swoo.co.uk. This is another .NET tutorial. In this tutorial we're going to go back to basics really and cover how to use constructors and deconstructive methods when creating objects in our code. So without further ado, let us jump into Visual Studio. We're going to create a simple console application. We're going to call it con-decon. We'll create that, wait for Visual Studio to create our initial program class, which is here. Now let's get started. First thing I do when creating a console application, because we're going to be outputting the results of all the functions and stuff to text to the console, we just need to ask for it to wait for us to press enter before it terminates the program when it's finished running this main method. So the way to do that is just console.read line, and it'll wait for you to enter any character really, or press enter. Right, so let's crack on with. What we normally do is with programming tutorials is use the car analogy. I know everyone's used to that type of analogy, so let's go for it. Let's create a car object. Now, one property of a car is its color. So let's create a property. This is all fairly basic stuff, so I'm just going to blast through it. Color. So there we have a basic car object with a property. Now, when you're creating the initial constructor, a constructor is just a method that gets run when you create this object. So if you create this car object, there should be a method that allows code to run to, I don't know, take care of any housekeeping tasks such as setting up other objects or setting up session variables or something, anything. Even if in this case it's simply to write to the console to tell us that we've just created the object. So let's set it up. All it is to create the initial constructor is that it's just the name of your class in a public method, and we can say console.write. We have just created our car. So let's go back to the main program. We need to create our object. So with car, my car equals new car. So what will happen here is all the console will do is output, we have just created the car. We just created our car. So there we go. Happy as Larry. What I want to do is I want to see what color my car is. So I'm going to say console.write line. My car is colored. My car.color. So this will attempt to write out the color property, which is in the class. Obviously, we have the string value of color. It'll attempt to write that out with my car is colored and whatever that property is. So obviously right now my car is colored nothing because we haven't specified a property, and we can easily do that by saying my car.color equals purple. Save that. So we run that. My car is colored purple. When we run, there we go. My car is colored purple. All good. So let's get rid of that. We want to put that purple value as the default for any time we create a car object, or in fact let's say black, because cars used to be black. It was Henry Ford who said you can have any color, a car in any color as long as it's black. So when we create a car, we're going to say color equals black. And if I go back to here, if we run this now, when we create this car object, the color property will be set to black, and it'll output my car is colored black. There we go. However, if I wanted to create this object sort of further on in the production line, and it had already been resprayed, and I wanted to do some work on it, I could say my car is orange, because everyone likes an orange car. However, we have no constructor, we have no way of putting this property in. We could do something like this. Color, laptop keyboard, my car.color equals orange, and we can override it. So now if we run this program, we've set the property manually, my car is colored orange, so we have actually overridden the default. However, we could, instead of setting hundreds of different properties, we could just instantiate the actual object with the color itself. So we can actually set it as we can set the property as part of the constructor. The way to do that is to create a new constructor which accepts the value of a color. Now let me explain this a second. Oops, I missed that bit off. So we've created a new constructor which accepts a string value of col, which is presumably going to be orange. But this constructor will also inherit the initial constructor. So if I set the color property equals col, which allows that value to be placed into that property, what you'll probably see is now, if we go to program and say orange, you'll see if I put a little note in here saying the default car color is color, what we'll see is, if we follow this through, we'll say we just created our car, the default car color is black, so we're here, but because we called the second constructor and specified a color of orange, it's called this, it's set the property, and then when it is deferred back to the main program and we're outputting the actual color of the object, it knows that the car is orange. It's actually overridden the default value in the default constructor, if you like, with the value that we specified in the override constructor. So that's basically how simple it is to specify overrides in a constructor. You would normally have what you would normally have is, if we go back to the car class, you would normally have your standard constructor and you would set default values. I mean, we could let's have another property. Oops, we're still running. Stop. Let's have another property. Public int num wheels get set. We could just say wheels equals 4, and if I output console.writeLine, my car has my car.wheels. We can see if we run that, it's going to have 4 wheels regardless of which constructor gets called, because remember, we're still calling the override constructor, but because it's inheriting the initial constructor, it still knows that the property of num wheels is 4. Now, if I wanted to override that as well, I could say let's add another override. We'll say int wheels. We could say wheels equals, in fact, let's do it. Let's go the full hog. Let's create another constructor. Just copy and paste that. We can have one where we can specify the color and the wheels. So what we can do is, where are we? Equals, num wheels equals wheels. Naming conventions here. Misspelled that. Can't be bothered to type. So what we can do is, this is actually going to, it's going to call this constructor. It's going to ignore this one because in this main program we're not actually calling the number of wheels. So let's run this, and the wheels are going to be 4. It's coloured orange, it has 4 wheels. If we, however, entered 10, we've got a bit of a beast of a machine. It's not going to call it's not going to call this constructor anymore, because we're also specifying the number of wheels. So it's matched two property values, 2 parameters. So this is the constructor that will be called. So now what we'll find is the colour will still be orange, but it'll say my car has 10 wheels because we're actually specifying that as part of the constructor. So let's run that and say my car has 10 wheels. Now we can create another constructor which doesn't accept the colour but accepts the number of wheels. So we can say int wheels. Num wheels equals wheels. So we've actually got 3 different constructors. So what I could do is I could also have that. Now, because we're not overriding the colour, the car will be black. Default colour is black, car's black, but it now has 10 wheels. And you can see the different constructors when we actually come to create the object. So we're going to create a new car, and then we have one of 4. We have a default constructor, which is just no overrides. We have one where we can specify the number of wheels. We have one where we can specify the colour as a string. And we have one where we can specify both a string for the colour and the number of wheels. If we don't specify either, the car will have 4 wheels and it will be black because we're not actually overriding it. There we go. Car's black, 4 wheels. Now, if we wanted to kill the car object, we want to know what's going on. We want to know when it dies. And the way to do that is to use a deconstructor. And to do that, you don't actually have to make it public or anything like that. You just use the tilde character and you give it the same name as the class object. This will be called when the car object is discarded or garbage collected or whatever. So what we can do is right line, the car has crashed. It had it had wheels. So what will happen is when the object gets killed or when the program ends, this deconstruction method will be called against the object, and we'll still be able to pick up that property because we know about the object, but this gets called when the object dies, just so we can track what's going on. But it might be difficult to show that, but we'll try anyway. So we've still got a black car, it's coloured black, 4 wheels, waiting for input, and you should see a flash of this car has now crashed. There you go. I don't know if you saw that, but it said this car has crashed, it had 4 wheels. We may be able to get away with asking for input. Read line. Let's see if that makes any difference. Oops. Car's 4 wheels. There, it has 4 wheels. So if we use one of our constructors, we could say, let's say it has 3 wheels. We just created a car. Default is black, car's coloured black, my car has 3 wheels. If it crashes, it's because it had 3 wheels. So you can see the whole life cycle of creating that object. We can see what's going on, and we can do things. You might have a user object that, you know, when it's created, you might want to write things into the database. And likewise, if a user object ever gets killed for whatever reason, you might want to kill the session or something like that. But this is how you do it. You use the constructors. You can do construction overrides using the different parameters, and you can also take care of what happens when an object gets killed. So I hope you found this helpful. I know it's a little bit long-winded as I normally am, but hopefully there's plenty to follow here. It's quite simple. If you like the video, please thumb it up. If you wouldn't mind subscribing, I'd be really grateful. And I look forward to seeing you in another video. Thank you for watching. Alright, cheers.